All right, 10.3, here we go, parallel circuits. All right, so again, we're going to use that I equals delta V over R. And then to do parallel, it's going to be 1 over RP, 1 over R1, plus 1 over R2, plus 1 over R3, plus the rest of the story. All right, so here we got 3 resistors are connected in parallel, all right, and placed across a 30-volt battery. To find the equivalence resistance, that's going to be 1 over Rp equals 1 over 15 plus 1 over 15 plus 1 over 15. All right, so 1 divided by 15 plus 1 divided by 15 plus 1 divided by 15. That would be 1 over Rp equals 0.2. Now, notice, this is still has the variable that we're trying to find in the denominator. All right, so I'm going to do the inverse of that, which is basically 1 divided by 0.2. So 1 divided by 0.2, my resistance in that parallel circuit should be 5 ohms. Remember now, anytime we get a parallel, the total resist or the equivalent resistance or total resistance from it should be smaller than the original one. Okay, what is the current running through there? So we want I, well, it's going to be 30 volts, right? And that's going to be over the resistance total that we had, which is 5 ohms. Okay, 30 divided by 5, that should give us 6 amps running through there. Okay, current running through each branch. Now, the thing about this current here is that when we get there, right, we're going to see this basically happen. Okay, so our voltage, even though those are all 15 ohm resistors, that 30 volts is going to continue to run through all 3 of those. There's nothing to stop it. So when we see that, if we want to know that I value, the current through there, right, that's going to be 30 volts, because each one is going to experience 30, divided by 15 ohms. All right, so 30 divided by 15, that's going to be 2 amps. So that'll be for each 15 ohm resistor. Because they're the same size, they're all going to carry the same amount of current through it. All right. So suppose that one of the 15 ohm resistors in 15 is replaced with a 10 ohm. Oh, all right, I got you. All right, so boom, boom, boom. All right, so 15, 15, and 10. All right, so that's going to be ohms, ohms, ohms. All right, and that's going to be 30 volts. All right, equivalent was, does it change? Yes, it should change. The reason it should change, 1 over Rp equals 1 over 15 plus 1 over 15 plus 1 over 10. All right, let's change this up here. So there. So now 1 over Rp equals 0.23 repeating. All right. So here again, I'm going to take the reciprocal. I'm going to take 1 divided by that. 1 divided by that answer. We find that the new resistance is going to be 4.3. Let me go one more decimal, sorry. So that's going to be 4.29 ohms. All right. So what we saw was by having a smaller amount of resistance on one, it actually makes it a little bit smaller there as well. Does this change? Yes. The reason is now we got a different resistance there. So I equals, our total resistance here is going to be different, right? So we're going to take 30 volts divided by 4.29 ohms. All right, so 30 divided by that answer, we see now our current is going to be 7 amps. All right, so does the amount of current through the other 15 ohm resistors change? Yes. If we now have 7 amps running through it, we should see that this should be different, right? So we take our well, actually, hold on. No, it's not going to change. We'll just get more through the other one. So we're going to get our current here is still going to be 30 volts over 15 ohms. all right, our current here will still be 2.0 amps. What will change, though, is, so that's for each of the 15s, each of the 15 ohms. Sorry, I got ahead of myself earlier. But what will change is that 30 volts, when it runs through the 10 amps, we'll get 3 amps there. So we'll actually get more current running through the lower resistance one. All right, and that's not amps, that's actually ohms. Okay, so that's where we're going to see a change. All right, the 150 ohm branch in a circuit must be reduced to 93 ohms. A resistor will be added to this branch to make this change. What value should be used and how must the resistor be connected? In order for this thing to be reduced, this resistor has to be in, oops, I spelled that wrong, in a parallel setup. That's the only way we can get that resistor to actually get lower. So, if we know now that we've got a resistor here that was 150, right? And then we don't know that other one, but we want this thing to get down to a total of 93 ohms. The only way we can do that is say, all right, 1 over 93, because that's going to be our new total, because we want this thing to have to be reduced altogether down to that 93, is going to equal 1 over 150 plus 1 over that R that we don't know. All right, so 1 divided by 93, 0.0108 equals 1 divided by 150, 0.0067, right, equals 1 over R. Oops, I'm sorry. That's plus 1 over R, the thing we don't know. So 0.108 minus 0.0067, we see here that 1 over our one that we don't know is going to equal 1.10. Gosh, bless it, folks. Sorry. 0.1013. All right. Inverse that. 1 divided by that. The one that we have to put in there has to be, so 1 divided by 0.1013 is going to be 9. No, that's not right. 1 divided by 93 minus 1 divided by 150. That's my mistake. All right, let me go back up here and clean this up. So this actually, so when we subtract the 0.067, 1 over our unknown actually equals 0.0041. 1 divided by that, basically 1 divided by that to flip everything. 1 divided by that answer. We should see this is going to be 245 ohms for us in order to actually get it to be reduced. Okay, the other number unfortunately was too small. All right, equivalence resistance of these three resistors. All right, so 1 over RP, 1 over 680, plus 1 over 1,100, plus 1 over 10,000. Holy man. So 1 divided by 680, plus 1 divided by 1,100, plus 1 divided by 10,000. Say 10,000. Nope, that's 100. Okay. 1 over RP equals 0.00248. Take that with a 1 divided by. All right, 1 divided by that answer. We should see our new equivalence resistance is going to be 403.3 ohms. All right. Okay, so the battery here gives us 110 volts. All right, so if we can figure out the total voltage, then we know that that's going to get split across there, right? So what we end up seeing here is this one experiences 110 volts, 110 volts, 110 volts. All right. So by knowing the total, it gives us what we should see A2, 3, and 4 add up to. But for A1, we need to know the total resistance. All right. So 1 over RP equals 1 over 20 plus 1 over 50 plus 1 over 10. So 1 divided by 20 plus 1 divided by 50 plus 1 divided by 10. All right. So 1 over RP equals 0.17. Take 1 over that. Basically 1 divided by that. So 1 divided by that answer. We find that our equivalent resistance is 5.88. All right. So to find our current, I equals delta V, which is 110 volts, divided by 5.88 ohms. All right, 110 divided by that. We see this should have 18.7 amps running through it. So that's what this A is going to be. So all of these three have to add up to that. All right. Now, we don't need the total current to find the other stuff. What we do need, though, is we need the voltage, which is 110 volts, divided by 20 ohms. So 110 divided by 20, that's going to be 5.5 amps there. All right. So for 3, that's going to be I equals 110 divided by 30 ohms. So 110 divided by 30. That's going to be 3.67 amps. All right, we're getting closer. So those two together are what? 9.17. All right. So then the fourth one, again, we could take, because our total here equals I2 plus I3 plus I4. We know our total is 18.7. 5.5 plus 3.67 plus the fourth one. 5.5 plus 3.67. We could subtract by 9.17 and find that I4 is 9.53 amps. That's one way to do it. Or we simply go ahead and say I equals 110 divided by 10. Oh, wait, that equals 11. What's going on here? Equals 11 amps. 50. Oh, what am I doing? Oh, that was 50. Oh, that's where I messed up, folks. I caught it. Caught it. That's going to actually be 50 there. So this here actually should be 2.0 amps. So if we know that, that cleans this up. So this should be 2.0, right? Let's just double check that other one. 110 divided by 20. Yep, that's 5.5. So minus 7.5. All right, 18.7 minus 7.5 gives us about 11.2 amps. I'm just wondering if this total is actually right here. 1 divided by 20 plus 1 divided by 50 plus 1 divided by 10. 5.88. Yep, 18.7. All right, sweet. So we end up seeing that we're a little high, but that's what we end up getting. All right.